Okay, so last class we stop where we are discussing database replications, and this database replications we have studied the multiple kind of strategy like master and slave replication strategy, and master replication strategy, and similarly we discussed the peer-to-peer replication strategy or architecture. So there is a in a terms of masters and master and slaves, master one and slave can be many, and master is generally responsible to take right operations and they are replicate to the other slaves, right? This is the master slave architectures. And in the case of master to master, not only one master but all the database, whatever the database designing deciding replicas, all are the become a master, and each masters, this master know I have a replicate this data in the 5 copy. Similarly, this master know I have to replicate data in the this master. Similarly, this is also know replicate here, replicate here, replicate here, replicate here. So in this case, each database is a multiple master database. And similarly, last architecture discussed about the peer-to-peer. So here, no master and slave concept. All the database are the equal capability. All the database are the equal capability. And this no, I have to replicate. They are going to replicate the near our peer, just to the peer, and they replicate to the peer. 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 In this way, all the database are the same capability, same read write operation they can perform. So initial confusion happen. What the differences between the master to master and peer to peer? So we discussed master to master generally use in your financial domains where data consistency is very required. So in this case, due to that, each master is aware other master and replicate data to them specifically. So here our masters ensuring that I am master, so all the master they have a 10 replica factor, so they know every 10 or masters they are going to replicate. Similarly, this master also know I have to replicate another. So here we are ensuring that data is replicated by another. But in the case of peer-to-peer, each peer is not aware to the other peer, but replicate data to the any peers that is available. So here in the peer-to-peer database, all the peer-to-peer database, he is available. This is available, they are going to write. Here available, they are going to write. Maybe somehow this is down, they are not going to write here. Maybe whenever up, then the new data going to write here. So peer-to-peer, this is the some kind of a less consistency, but they have a highly available, highly scalable, highly flexible, you can say. So if you are let's talk about some points. So if you are designing the master to master or peer to peer, that means your master to master generally use for your all kind of financial transactions, and here peer to peer basically all kind of big data analytics, real-time analytics, IoT data processing, such where peer-to-peer replicas generally use. So here scalability, both database provide very high. Availability, both are architecture provide very high, but consistency is a very high in the master to master, but consistency is the low in case of peer to peer, because peer to peer somehow sometimes we are not provide high level of consistency, but flexibility is very high in the kind of a peer-to-peer database, and flexibility the very low in the master to master database, because generally they are very rigid and strict consistency rule apply so that we ensure that every data we are not going to the lose. And other parameter, latency the low, and if you talk complexity is very high here, because master to master configuration is there are tough challenges to how to configure, and peer to peer is very simple. Similarly, conflict, if something conflict happen, very complex to handle those conflict scenario in the master to master. peer-to-peer is very easy, just replace with the new one. And similarly, if you're going to configure this master to master configuration is very complex, and peer-to-peer configuration is very simple. Just remove one node, add one more, add one more, add one more, because they don't know, there is no such requirement every peer database node to other peer. But in the case of master, if you add one more node, you have to inform every master node, hey, this is a new master node is added for the replica. You have to replicate here as well. So here need to more kind of complex configurations. So ensure that master to master configurations are the mainly is for very high kind of consistency and high availability. But if you want peer to peer, very high level of flexibility and low level of consistency, you can say. So here say peer to peer generally define the high scalability and high flexibility, and if you're designing the master to master, means you want to high availability, available always, but consistency always also required. So high availability and high consistency, master to master application. Here high availability and high flexibility, if you want different schema, different vendor, different kind of data. So generally we prefer peer-to-peer replication. So database replications is, while scaling, you also ensure to replicate your data. If you talk some, I'm going to talk about some use cases. So here our all the e-commerce website generally replicate replication ensure highly available and performance customer accessing product information and everything. So all the e-commerce application generally replicate, use the replication strategy so that he is always available, data is always available. And simply all the social media platforms also use the distribution of load, heavy read. So for those fetching customer data and posting update everything from every locations, so they are using also replication factor. Similarly, financial institution like any critical financial data should be available and even in the up to date across the multiple location. That's a good example about if you are talking about the trading system, stock market, different across the country, all the persons are doing the transaction trading, and everyone should be see the consistent behavior across the location, right? Every data center must be updated the same copy and data cannot be lost somehow. So we are ensuring that master to master replication for all the financial number and institution must be taken care. If we talk about the database replication, so what are the challenges or all the benefit we discuss? Our database schema is highly available, highly flexible, highly consistency, right? So while making multiple database server, scaling data, your data, multiple data, replicating, making multiple copy of the same data in the multiple places, we have to these add some kind of challenges, limitations to the system designer. So we have to increase the complexity. What do you mean? Here means so now we have to set up more configurations and management, because we are introducing multiple database server and each database server have a multiple copy they are putting. So we have to manage the data are properly copy, any server down, we have to up them. So all the configuration and management is become a complex, additional and complex work for the system engineer, DevOps engineer. And whenever you are keeping same data in the multiple location, multiple place replicating, you are increasing your higher cost, because same data you have to put 3 location or 4 location, you required hardware, you required storage device, you required maintenance, those scenario, anything replication strategy required. So this required additional hardware and infrastructure support these replicas. We are providing replicas on the basis of some cost, So we have to understand how much cost we are going to the pay to the storage device, to the cloud provider. We have to think where we are going to keep this replica, how long, how number of years. So we have to consider our cost characteristics as well as. And the challenges is also data inconsistency, because now the same data you are splitting into the multiple database, multiple region, multiple location, same data you are copying to some different places. So what happened, so maybe one same users, one user accessing data from here, and suddenly this from the different location the same data someone accessing, maybe the particular user profile, they be multi-tenant applications. Maybe we have a one my financial combined account, so I can also log in my banking system, and my wife also can log in the banking system. So let's say I am in one region of the world, my wife is another region of world, same time both are going to the login. So same profiles are replicated in the both regions. So what happened, I change something here, or this is quickly updated here, or this change something quickly updated here. What happens, some replication factor copy or paste something happen, so chances of the data inconsistency become high. So it ensure that we have to put extra effort, extra algorithm, so that ensuring that primary data and replica data must be available as a consistent, as a atomicity rule. And so we have to extra care to ensure that the data consistency problem cannot face by the customer. Similarly, we have some conflict also arise, because when the multiple replicas try to update same data simultaneously, what happen sometime, master to master, and this is the master, they also read the right data, they also receive the right data, both are going to replica to each other in the different master, and so might be chances our data can be conflict, data can be problematics. So in this scenario also we have to ensure that such data conflicting can be addressed properly with the properly techniques. Lots of algorithm, lots of technique available to ensuring that data conflict how to resolve, data inconsistent how to resolve, how to maintain not too much higher cost as well as. So we're not going to say, hey, put the 100 copy of every data, not maybe couple of, maybe 2 or 3 is the R4 is the very highest, because you have to pay the cost if you are putting same data in the multiple copy. A reason is that your data, why you are doing this, because you have a managing large data set, a large data, maybe duplicate kind of things, again multi folders of the larger data you have to manage, store. So storage capacity nowadays, cloud or in-house, you have to calculate all the things. So these are the challenges help us if you are scaling your database. Even all these challenges we have, still nowadays our technology, our framework, our vendors already provided this replication technology for us. We have to just aware, we have to just use them. If you talk about the replication technology, already if you are using the MySQL already have a inbuilt replication technology, and how distributing data across the multiple server. Just you have to know the architecture of MySQL, how to configure them, how to provide the different input to the MySQL engine, and MySQL engine did the replication for you. Similarly, if you are using a Postgres database, they already have a inbuilt replication technology available, so they're distributing your master data to different multiple server. Even the all are the primary major vendors of the database provider, maybe Oracle, maybe Microsoft, and whatever the database you are using, just look out the documentation, they must provide the replication strategy, how they are replicating data across the multiple database, across the multiple geographical locations. So even if you talk about the Oracle, MySQL, Postgres, every database, what are the basically use? Even if you are using the MySQL or MariaDB, synchronous multi-master replication strategy also provided by the combination of MySQL and the MariaDB. So you can say these the technologies already available. You don't bother how you to manage them. Just you should aware, hey, this technology database replication already available. If I am using the particular database, let's check what are the way we to configure to get the benefit of database replication from these technologies. Even if you are using the cloud-based services, cloud-based database, so all the cloud-based provider also provide the facility how you can configure replication means how you are ensuring that whatever the data you are receiving, you must ensure the 3 copy of data, 3 regions must be placed. You can talk about the Amazon, you can talk about the Google, you can talk about the Microsoft, all the big cloud provider. RDS is the relation for Amazon, relational database service for the replicating data across the multiple regions. They are support. If you are decided I am using the cloud provided services, they can easily offer for you. Even you can talk about the cloud SQL replication, Google fully managed relational database services replicating data across the multiple regions. Even you talk about the Azure also have SQL database replication strategy, Microsoft relational database services for replicating data across the multiple regions. All the, you can say, basic functionality of replication means keeping multiple copy of your data in the different regions are basically provided with the cloud services. So if you are using any cloud service provider, let's discuss they support this scaling of database and also replication of data. So when you are scaling data, you have ensure that this replication also required database scaling plus replication. If you do both in this way, your database is completely scalable. And if you talk these database scaling, database replications are used by the many applications nowadays. If you even Amazon use the combinations of MySQL and Oracle replication strategy to ensure the data available and performance across its e-commerce platform. So even the applications are not highly rely on only one database or one kind of database, multiple types, multiple vendor database they are using. Even Facebook also use the MySQLs and Apache Cassandra to make the replication, ensure that data availability and performance across it the social platform would be available. Even these kind of replication combinations of MySQL and Postgres replication strategy used by the NASA to ensure data available and application performance across its a global space exploration platform. Similarly, huge list here. You can talk about the Uber also using the multi-master replication strategy where they are using the Apache Cassandra to ensure the data consistency and availability across the global riding sharing system or platform. So you can say all these database scaling and database replication strategy are used by all are the big player. And even this is the good part, if you designing your systems and that system is handling large user traffics and you want to scale your data, yes, you can scale multiple database, you can scale so that your load can be distributed to the multiple database. While scaling, you also ensure that make a multiple copy of the data so that if some data are crash or down, another copy are available. So multiple scaling data, multiple database, And database replication, each data you are putting the multiple copy in the multiple region, so that your data consistency, data availability, data flexibility is handle your system. So whenever you are designing system, please ensure that your database properly scale, and while scaling you cannot lose some kind of a property like availability, like performance. If we have you are managing huge large data set, one database is surely become the bottleneck for the performance or read and write operation. Yeah, surely if you scale multiple data, multiple, now your request is distributed to the different database, now your application become scale, handle the large user request and even response quickly. If something happens, something problem, we already configure database replication strategy, multiple copy available for this data. If something crash, no problem, request is redirected to the another copy. So scaling of database and database replication both make your system is highly available and scalable. So these technologies, and even you don't worry, each and every how you can scale your data, how you can replicate your data, already database vendor, whatever the software you selected, they offer us, just we have to configure them, we have to tell them, just use the documentation how to configure master to master, peer to peer, master to slave. They have just configuration required, you can do, and everything is taken care of. Even you are using the cloud provided services, they just ask them, configure them, hey, I want here the database must be scale and database must be replicated, replication factor should be the 3, yeah, replication factor should be 5. So 5 instance, 5 copy of every data are managed by your cloud service provider in the different region. Something happen, disaster happens, something failure, hardware failure happens, something software failure happen, still you have a copy of data, you can serve the request. So if you are designing system that are going to handle huge user traffic, or they are going to the process large data set, in those scenario like a big data analytic, like IoT, like financial data, where your data chunk is very high, very large, then you must scale your data. Multiple database can handle the request, and each database you also ensure that you are applying the replication factor, means ki same data are putting the multiple copy in the different places, different regions. So this help us to designs our system to capable to handle large user data traffics. Hope this information helpful. Thank you for watching.